I'm Lloyd Hughes of the NOMMA Education Foundation. I'm here today with Chris Meitner of Christopher Metal Fabricating for another in our series of instructional videos. Today Chris is going to show us the steps his company goes through to complete a series of steel stairs for a large commercial project. Chris, is this typical of the work your company does?
It's about half of our work is commercial oriented, the other half is residential. The commercial end, we do a lot of steel pan stairways with a concrete fill such as the one we're in right now.
And what does this particular project encompass?
We have 3 stairways in this project. 2 of them are very similar to the one that we're in right now. The other one is a curved stair that goes up 1 floor. In a few minutes we'll head over to the other area and take some field dimensions. It's a bare opening right now so that we can fabricate that next stairway.
And this stairway that we're in now, how tall is it?
This is goes up 3 floors, but I believe there's about 7 flights.
Okay. Well, why don't we move over to the other opening and do some measuring?
First thing we'll do is we'll check the width of the opening.
Okay.
Both ends, and then we'll check the length. Then we'll take a quick look up and down, see if there's any projections that may or may not be in our way. You notice that this 3 sides of this opening are block, masonry block, so they're fairly straight. The 4th side, unfortunately, is precast wall panel, and it's very uneven. So when we build the stairway, we're going to have to build to the narrowest point and build some adjustment into some slotted clips on our header channels. That'll actually carry the stairway. We'll check across. We'll gather our overall width for this wall here. We are 103 5/8 of an inch. As I mentioned earlier, this wall is very uneven. It's precast material, individual planks. So we are going to take the width at several points along here to make sure we get the narrowest point to work to. This area we are 103 1/2. Walk back 3 or 4 feet. We are 103 and about 3/4. And we'll continue that same thing throughout the opening. Now we're going to measure the length of the opening. Lloyd will take the end of the tape to the far end of this opening. We will check this both against this wall and against that wall there. Same as we did for the width of it at several different areas to make sure that the width is somewhat consistent. And over here we have a total length of 207 1/8 inches. Now we want to make sure that we know finished floor to finished floor, because that's what we have to build to. We need to know that this floor I'm standing on is the finished surface, where they can put wood on it, they can put tile over it. If so, what that thickness is going to be. The same thing goes for the 2nd floor. We need to know where that finished floor is in relation to this finished floor, where the subfloors are that we're actually setting our materials down on or fastening into, so we can make all these adjustments when we actually manufacture that stairway. So just take the tape down. We are 139 5/8 of an inch, floor to floor. And that will determine our riser heights. Floor heights do not always work out the way they're supposed to on the original plan. That's why you field dimension, you go back and you have to re-detail to make sure that you have the correct riser heights to get from one floor to the next.
Now for the outside stringer, will it attach directly to the wall or does it sit on clips that support it?
Okay, there will be a header channel. I believe there's an 8-inch, 11.5-pound header channel that'll span from this wall to that wall. The expansion bolt would be a whole cord in that blockwork for the channel to actually physically set in the wall. On this side you can't do that, so they'll have a clip and expansion bolts. As I said, this is very uneven, so this header channel will have slotted holes in it to make sure that it'll work at this point.
Okay.
Any header channels on up will then they'll be made the same. They'll be able to move that slotted clip a little bit further out or a little bit in to make sure we make the span all right.
So the fact that the wall varies, that doesn't affect the actual stringer and the width of the stairs?
No, like I say, we will build the stair to the narrowest width. There is a little bit of take up between the 2 center stringers, about an 8-inch space, so that when we get here with the stairway, we can push this stairway up against the block wall, this set of steps up against this wall, then we put that fill-in piece between them afterwards. And then we Again, when we do multi-level stairs, we field measure after the stair is in place before we build railings for it.
Okay. Now, a project like this, what does code tell you the width of the stairs have to be?
The minimum width, I believe, on a stair here is 44 inches.
And the rise and run?
Okay, the rise and run, on a commercial building, it cannot be any greater than 7 inches, no less than 4 inches. The run or the tread length can be no less than 11 inches.
And that's from nose to nose?
Right, horizontally or vertically.
Now, if this were an exterior stair, would the treads be pitched slightly to allow for water runoff, or is that not?
Up in these northern climes, we don't have too many exterior concrete stairs. They don't last real well, because what generally happens, if you got an exterior stair, you're going to salt it, and that salt will eat away the steel stair in a matter of 10 years' time. But when we do it, yes, we do have a little bit of pitch to that, each of those treads.
And that would be just 1 or 2 degrees? Or...
Right, just enough to get water to run towards the leading edge of the tread. Okay. One other thing you need to make sure you check is take a good look at the surfaces of the walls, see if there are any projections in your way. For example, up high there's a pipe sticking out. From down here it appears that that pipe is well below our landing and won't be in our way. It will cause no interference. Down below here there's another pipe. Again, appears not to be in our way, so we don't have to worry about it. But these are the types of things you have to be aware of so that you make sure your stringer isn't coming right across this particular light fixture and closing it off. You have to address that problem before you bring the stair out here, whether they move the light or you change the stair. Another thing you have to do is be aware of where these stair openings are. Take a dimension to locate that, the door opening. To locate this door opening. Don't need to worry about it on this level, but at the second floor we need to make provisions in our landing so that we can actually walk through that without having to step over the stringer. One last thing we have to do before we leave is check the squareness. We want to work off one wall with regards to the 2 end walls. Again, as I said earlier, this wall is really very uneven, so we don't want to use that. This is a nice masonry wall, so we are going to check the squareness of this corner, then we'll go and do the opposite corner as well afterwards. So one way to do that is to have some kind of large square device to put up against the wall, or you can rely on the old Pythagorean theorem. In other words, if you have a 3-foot leg of a triangle, a 4-foot leg of a triangle, that hypotenuse, which is this diagonal, should be 5 foot. And that will tell you that this corner is absolutely square or 90 degrees. I don't like to go when I check things, I like to go the largest dimension I can. So we're going to double that. The Pythagorean theorem is proportional. So if you can go 3, 4, 5, you can go 6, 8, 10. That's what we're going to do in this case. So Lloyd, you hold this and mark that at 8 feet. Okay. Now we'll go this other direction, and I will mark this at 6 feet. And then that dimension from that 8-foot point to this 6-foot point should be 10 feet if this is absolutely square. Now, as you can see that we went 6 foot, 8 foot, should be 10 foot across here, and this is 10 foot and possibly a 32nd of an inch. That tells me that this corner is very square.
We've completed our field measurements, and now we're back at Chris's shop, where Chris is going to develop the shop drawings needed to complete the fabrication of our steel stairs.
This is a typical detail drawing taken directly from a shop print that the guys will fabricate from. This and the following overheads are all taken off the same blueprint. Here we have this line and that line drawing the perimeter of the stringer channel, which is a 12 at 20.7 pound stringer. These are bar stock carriers, 1/4 by 1 bar stock. They are the support for the pans that create the steps. The stringer itself is the main structural support that holds the whole stairway up. This black line here is a 14 gauge or sometimes a 12 gauge pan, which creates the actual area to fill with concrete for the actual step. This line here is the nosing line. Your detailed drawing will tell you how far from the top of the channel they want that nosing to be. Typically it's 1.5 to 2 inches. There may be a reason to want that to vary. The single most important element in stair fabrication is the relationship of the rise and the run. You can make a mistake building a stairway, whether you make the ends too long or too short. It's a fairly easy fix. But if you get this relationship of the rise, which is the vertical height from this nose to that one, measured out here strictly vertically, and the run, or the tread length, in this case 11 inches measured horizontally out from this nose, directly above that nose. If you don't get that angle with the world right, the stairway can be thrown away. This plan view of the stair appears a little bit distorted after being projected onto the screen. The idea here is to show you what the component parts are. Along this wall is a continuous stringer from one end wall to the next, made out of a C12 by 20.7 pound channel. The piece mark is 2S3. Along the back wall is an end wall channel, 3C3, again the same 12 at 20.7 pound channel. Another wall stringer all the way along the bottom here, and another end wall channel here. This dotted line represents a header channel, one there and one here. These are attached to the wall channels, and they carry the center stringers. These channels are to support a 9/16 corrugated type deck, which will create the pan for the concrete fill in this landing area. Here's a typical detailed drawing of a wall stringer. Again, called out as a C12 at 20.7 pound channel for the stringer. We have our 2-inch dimension here, tell us from the top of the channel down to the nosing line. Here we have a clip angle that's going to carry a header channel which will support the center stringer. A carrier angle that will help support the decking on the landing for the concrete fill. A couple holes here for a connection clip to the end wall channel. These are the 1/4 by 1 carrier bars which actually support the 14 gauge pans that will be filled with concrete. On the lower end we have another clip angle for a header channel, another carrier angle for decking again, and you'll see that this particular stringer has also been cut and chipped, more than likely for another door opening. Up here we have what's called nosing stubs. These are to help the fabricator lay out these particular points, whether it's the actual point of the carrier or the point of the nosing. That dimension will be the same, just where they locate on that stringer will be different. What they'll do is they'll measure from here to there 1 foot 1 1/16, just as this dimension says. They will then hold their tape at this point. They'll probably use a vice grip or a clamp of some sort to hold that tape, stretch it out, and just mark the stringer at each one of these measurements. That'll give you a much more accurate dimension totally from here to there, and that is singly the most important dimension on this stringer. This is a typical center stringer detail. Note there's no tails at the top to create a landing or at the bottom. This tells you right off the bat this is the center stringer. Here is a little clip angle which is to ease an erection. It'll help the erector support this in place until it's either bolted or welded. Looks to me like this one is intended to be welded. There are no holes for a clip angle or a clip angle evident. You have the same 2-inch dimension here. You got the carriers called out. This particular stringer is not the mate to the last one. It goes to the same stairway, but you will note that this nosing, the nosing length and the stub dimensions are different than the last one. Within any one particular flight of a stairway, the rise and run has to be the same. But as you get on a landing and go up to the next flight, that rise and run can change as needed. This is a detail of a header channel. Note the holes at the end to tie into the clips on the stringer. This particular stair, this end of the channel will pocket into the masonry wall. We have clips here that are going to hold the 3-inch or 4-inch channels that will support the landing deck. This channel is a wall end channel. Again, a clip angle tying it into the stringer on one side. Nothing on this end means it will pocket into the masonry wall. The carrier angles for the deck support. Clip angles for the support channels for that deck. Down below we have one of the deck support channels. Bolt holes, again, to attach to these clip angles. This is a pan schedule for that particular stairway. This would be a typical starter pan. This will be down at the very bottom of the stairway. It's simply a riser plate. From that point on, you have the tread and the riser as an integral part. When you get to a landing, you need a little filler piece from the header channel to the back side of this riser. Some other special pans are occasionally needed where the tread length is a little bit shorter than normal, or, as in the case of this one, a little bit longer than normal. This is the detail of the beginning stringer at the main floor. In our discussion there, we talked about being cognizant of what the finished floor height is. We need to know that from this nosing point down to the surface we're sitting on is either the finished riser height, or whether we have to build in some extra depth there for a piece of tile or wood or whatever the flooring might be, possibly carpet. This is Chris Meitner once again, back at the office, here with Rick Ewell, our project manager on this particular project. He would be the one that normally would go out into the field and take those field dimensions we looked at earlier. Before us we have an original drawing of the floor plan of that stairway. This was made from the architectural drawings, and if this were a perfect world and contractors built buildings exactly as called out on the drawings, we could build our stairway from that. But as you saw in the field, conditions vary tremendously. So we have brought the field dimensions back. Rick will now take these field dimensions, replace the original dimensions here as necessary to create a new drawing that we can put out in the shop for fabrication. On the screen now we have the same drawing that we were looking at on the table a minute ago. Our computer allows us to do some things much more easily, much faster. For example, all we have to do is put in the parameters for the stairway itself, the height difference between landings and such, and it will calculate those nosing stubs we talked about earlier. There's certain calculations we don't have to do by hand anymore. Right now Rick is blowing up the area where we want to make a dimensional change on that landing channel. It may look Greek, but Rick doesn't understand it. As we saw Rick make the corrections to that plan view, he also had to make corrections to each of the detail sheets for the individual stringers and other component parts such as header channels. That information is then sent from the computer over to the plotter, and once it's plotted, the new original will then be used to create a blueprint that will be sent out into the shop for fabrication. I'd like to point out at this point that a computer system is not required to be a stair fabricator. We happen to have the luxury of such an item and the luxury of a person that can understand the machine and utilize it. I myself would draw these by hand. I have no clue how to use that computer.
Well, Chris, now that we've got the measuring completed and you've done your shop drawings, I guess it's time to start the actual fabrication.
Right.
But in order to do so, I take it you need a certain number of tools for the layout. Maybe you could explain to us what you have here.
All right, in front of us are the tools that will be used strictly for the layout portion of the fabrication. Start out here, we have a framing square. We've put a little enhancement on this framing square. We've added a couple of little clips which help us to locate it more readily on a piece of material so you're not fighting on the edge. This thing just slides right up against it. When you make it, you have to make sure you get these tabs aligned properly.
That would make sense.
So you maintain your squareness. Another framing square that will be used in conjunction with this alignment bar, if you will. This is what we will establish the slope and draw the lines for the steps on the stairway itself. This little gizmo goes together like so. You'll see how we put this together in a little bit. Combination square. Got a small bevel square, a large bevel square, straight edge. Of course, can't do anything without measuring tape, layout pencils. Some guys use soapstone. I myself prefer the silver lead.
Do you think that they hold up better? That your lines aren't obliterated as easily as with soapstone?
Myself, I like this better. I think I get a finer point with it. Some of the guys in the shop would differ with me. Of course, a couple of wrenches, simply just to use to tighten down this little gizmo here. Really don't need this in the layout portion of it. Safety glasses at hand. One last thing that we need, if we're over 40, a pair of eyes. Here we have a mock-up of a full-size stair, miniature version, so we could put it together for this video. I'm going to give you a preview of some of the elements used in this, so when we discuss this further on in the video, you'll have a better understanding of what we're talking about. This piece here is the stringer. It's the structural support for the stairway. Attached to that, just as a decorative piece, so you don't see a hollow opening, there is a closure plate welded to the front of it. There is a clip angle that will expansion bolt to a concrete floor, or if in the case of it's attaching to structural, could bolt to it or it could field weld to it. These pieces here are 1/4x1 bar stock. They are called carrier bars. They support the steel pan that will be filled with concrete to create the step. This is an 8 at 11.5 pound channel. It is called a header channel. In this case, it's bolted to the stringer. Sometimes it's field welded. It all depends on what you're trying to accomplish. This will be the support for the center stringer, which is the partner to this one, which holds up the other end of the pans for the stairs. This is another carrier angle, it's called. This supports some decking that will be laid flat on here, and then the concrete fill to create the landing will be poured on top of that. This is a back wall channel. It has a bolted connection. Sometimes it's welded. It has a carrier to help support that same decking we talked about. This is the center stringer I had mentioned just a minute ago. You'll see that from the bottom it duplicates the outside wall stringer. And when you get up to the landing area, it does not have this tail for the landing because you will have to walk around it and continue up the stairway. So it has just a vertical cut that will be placed right up against the surface of this channel, just as such. And then the pans fill in between there. You'll step up, walk around, continue on up the stairway. I have in my hand a 14 gauge steel formed pan which will create the form for the concrete that creates the step you will step on. It has a raised lip in the front. That lip will butt up against the back side of the next riser of the next lower step. We're going to be getting further discussion of all these elements later on in the video. Okay, well, the first thing we're going to do is we have to set up our slope for our stairway. We do that on the bench here. Referring to our print, we have a riser height of 6.5 inches, a tread length of 11 inches.
Okay.
So just note that down, 6.5 to 11. Now if I lay that out on a real small scale, my odds of having an error are much increased. If you will.
A degree off here is magnified.
Right, so I will double this at least. All right, so we'll go from 6.5 to 11 to 13 to 22. So our riser height will be 13. Mark on the table at 13. This is where the square would... Now, before you use the square on the bench, you've got to make sure you don't have any bad burrs along the edge either. Because with your luck, right where you put that tab,
From all the times you probably
Right.
welded something
Yes.
on your table there.
there's all kinds of little burrs. So. Draw a straight line. We've got a nice square edge here. This represents a riser. And we'll take our tread length and run this way. Again, twice 6.5 was 13. And we'll go 22 inches this way. Be a little bit more accurate. I will hold it right on 10 inches. Go to 32. I have so many marks on the bench that usually I put a little hash mark on it so
Okay.
I turn away from it, I know which one I left behind. This is where we use the straight edge. Connect the dots, as they say. And this is the actual slope of the nosing line going down the steps if this were a vertical surface. So now we take...
So in this area here, you could actually draw in 2 risers and two treads.
Yes,
Yes.
that's correct. We'll take this little device and adjust the framing square to match that slope. Tighten the framework to it so it won't move on you while you're using it. And snug it down pretty nice. Make sure you're still running parallel. Make sure there's no movement in this way on the burr. Finish tighten it so it won't move on you while you're trying to use it. On occasion, this thing will fall to the floor, and then you have to take it and bring it back over to this layout, check it, make sure it hasn't moved on you. As I said, the most critical thing about a stair is that slope.
Exactly.
Okay, Lloyd, what we have here basically is the riser, the tread, and the edge of your stringer. Okay, the first step we have, here's the channel that we're going to create the stringer out of. You have to deburr it, just like we talked about deburring the edge of the table, to make sure there's no burrs in the way that could interfere with your layout tools, which is a real simple task. Okay, now that we've had the channel deburred, we're ready to start our layout. You notice that I put another piece of channel over there.
Right.
So when we do the layout on this one, we can just transfer it to the other.
So one would be the outside stringer and the other would be the inside.
Right. Mirror images of one another.
Right.
Okay, the first step, look at the print, and it tells us the nosing line is to be 2 inches down from the top of the channel. So you take your combination square, set it for 2 inches, and draw that nosing line right on the stringer. And since that is a mirror image, we do the inside. The drawing tells me that this first nosing is approximately 5 inches back from the farthest point of the stringer. So I'm going to pick a point roughly 6 inches from the end of my stringer and make sure I have enough material. I'm not drawing my layoff right off the end of it. Grab my tape just a minute. Come in from the shortest point, about 6 inches. We'll draw on that first nosing. Now, anywhere to the right of this point should leave me enough stringer that when I do my trimming, I won't end up, oops, got to move everything over. So, draw on the riser line, draw on the tread line. Now this is the finished tread. we will then be laying out for our carriers and such below it. Our concrete depth, I believe, is 2 inches. I don't have it on this sheet, but it called for that on the other one. So draw on a line 2 inches below, and this will be the actual line that our carrier sets, our panel set on, and the carrier, locate the carrier, right, right. Let me bring this right over here where it's a little bit easier to see so I don't have so much walking back and forth to do. On a typical stairway, you do not have a vertical riser.
Okay.
You normally will have a 1-inch setback for the bottom of your tread.
Right.
That gives you a little bit of toe room. And that 1 inch is set at the actual height of the tread. This is our height of the riser, excuse me. This is a 6.5 inch riser. So we'll go down 6.5 inches from our finished tread. Make a mark. Again, show you that if you want to see it. 6.5 inches from our finished tread down to where the next tread or floor would be. And take our square, draw in what is a horizontal line with relationship to the stairway. Come back 1 inch. Hand me that square there, will you? This is the actual angle that your panel will make. It does not come down square. You'd be stubbing your toes on the stairway if it did. It comes back with a 1 inch relief, gives you a little bit of toe room so you're not banging into that. Now we'll take a bevel square and set it for the right angle with the edge for this new riser line that we created. Got it set here. It's already tight, so we're all set on this. Again, this is now the riser line that we're actually creating for our pans. Okay? The next thing will be to go ahead and space out for each of our treads. Now what we're doing here is we're making a mini stair that time constraints will not allow us to build a complete
finished one.
right. But all the steps are exactly the same. So we go to the nosing stubs once again. This one doesn't matter that much. There's only 3 risers. You could just simply mark it off at 1 foot, or whatever it is. But we'll use the stubs. This is from first nose to second nose. It's 1 foot 0 3/4 inches. Again, start at your nosing. Got 1 foot, so we go to 1 foot 0 3/4. That's where your next nosing is going to be. What I would normally do, 1 foot 0 3/4. Take a vice grip or something, hold this in place, and we can just stretch this tape out, lay out every single one. In this case, we only have 2 stubs, so we're at 1 foot 0 3/4. The next one is at
2 feet 1 and 9/16.
2 feet 1 and 9/16. And we can double check ourselves here real quick. Again, 1 foot 0 3/4, 1 foot 0 3/4 plus, which adds up to those 2. We don't get any closer than a 1/16 of an inch. We do a make if these do not add up to 1 and 9/16, twice that.
Right.
But in the long run, these will make up for one another as they go along. We lay out the next step. Draw on your tread. Your last step is a finished tread. We can go back to this square and draw in our low riser. Now this riser has to continue down from the top of this tread all the way to where the pan is located on this one. You don't just simply stop it there, because your carrier is going to come all the way down here and your metal pan is going to come this full distance. Do the same thing on your top one. Draw in our 2-inch depth for the concrete. Since this is a landing, you check your print. Oftentimes the landing depth will be changed, so it's because it's a larger area of concrete, so they need a little more.
Thicker.
So in this case, the landing depth is 3 inches. So you draw on a line at 3 inches for the concrete thickness. Two inches again at this tread. Now I'm going to do a little bit more than we normally do just to show people exactly what's going on. I will go in and draw in those carriers so we get a better feel for what's going on here. I'll draw on that 1/4 inch thickness. Oops.
For the carrier, you bend the rise and the run out of one piece?
One piece. We'll take a piece of 1/4 by 1. That's what you normally use. Occasionally an architect will insist on using an angle or some other type of material, and then you're stuck doing it. We've found generally, no matter how it's designed, when we submit our drawings for approval, we always draw on the bar stock, much easier to work with, a bit faster, and more than adequate to support that pan. And most architects don't really care.
And the pan's getting welded in anyway. So
Right. Right. So it's you got the carrier holding it, and the pan itself, once it's in place, is welded as well. So again, here's your 1/4 inch carrier. You'll note that this pan, or this concrete thickness, is going to be different than the very bottom one, because here we're right on the floor. This one, you're going from this floor to basically that floor, if you will, plus the concrete thickness.
Right.
So this is a much taller pan than what the starter was. We'll go ahead and lay out the end of the stringer so we know where to cut it off and trim it. We have some dimensions given to us here. We want to be 2 inches in front of horizontally in front of the bottom nosing. And there's nothing magic about this number. Sometimes they'll call it to be 4 inches, sometimes they want it 6 inches, sometimes only 1 inch. Depends what the designer.
So it's just an aesthetic decision.
Right, right. Okay. Again, being the bottom pan here, we know that this is the actual floor. We talked about in the field, you need to know what's happening with the floor. This is finished floor height right here. If we had measured to a subfloor, let's say they had 3/4 inch of tile and grout,
Right.
we would have to extend this down another 3/4 inches so that we cut off our stringer where it's sitting on the subfloor. But when the grout and tile is put in place, it's raised up, so bing, here we are once again, our correct height for that step.
Because there's nothing worse than hitting that last step that's different from all the
Right.
others.
You see that a lot with residential builders and carpenters. They'll get this step too low and the top step or the other way around. they'll get this one. They'll forget to take into consideration the thickness of that shred,
Right.
and they'll make the same cuts everywhere. So consequently, this ends up being, in this case, 2 inches too high, and the top one will be 2 inches too low. Now we'll go ahead and continue this floor line through the edge of the channel. And this is where we'll make our torch cut. We'll cut it off along here and along there. This is the floor, and just for aesthetic purposes, they wanted to go 2 inches in front of that. This is a vertical line.
And then you will simply plug the end of that?
Yeah, we'll take a piece of 1/4 by 1.5 bar and close off the end of that stringer for a more finished look. Now the top, in this case, just set that over there for me. Now we have to figure out where it is this miter is going to occur, so we run parallel this way for that top landing. And that is determined by what height they want the top of the stringer above the concrete line. In this case, in most cases, they want a 4-inch kick plate. Sometimes it'll be different, so you have to pay attention to it. So they want 4 inches. So again, you mark 4 inches. Again, take your square out. It looks like I did it just perfect because I just barely make it to the end of the channel. Sometimes it doesn't allow you to be able to get this all the way across depending on the slope. But you can know that this thing is reversible. This is the same angle. Let me put it on this side of the line so you can see it. It's exactly the same whether you got the framing square there or whether you got it here. Now, we need to determine what angle to cut this off at so we can weld the piece on to go in this direction. The way you do that is mark 12 inches. It's over here so you can 12 inches is the width of the stringer going this direction. So I've come down vertically 12 inches. I will then extend that line, that mark, all the way over to the channel. So there will be a here and there. And that's where we'll cut the channel off at this point. We'll cut this off, make the same or the reverse cut on another piece to add on for our tail. Now if you happen to have a pair of stringers that each have a tail, you'll be able to use this piece that you cut off here on the opposite side, because this happens to be a reverse. Okay, the next thing we'll do is transfer our nosing points from this stringer to the opposite side. If you don't just transfer from one to the other, you could make a mistake doing one layout and not in the other one, and you'd have an uneven stairway. Incidents of that happened probably about 20 years ago in another plant. We sent a stairway 150 miles north of here for somebody else to install. When the shop foreman, of all people, just did not like to transfer. He laid out each individual stringer, and he had 13 steps on one side and 12 steps on the other. So what we'll do, slide this over a little bit without falling off. Okay, we just simply transfer our nosings right over to the nosing line. This point is right here. Transfer the point for the miter cut. We could then transfer this point all the way across, or just simply use the bevel square that we've got set up at this angle already. Go down and transfer our bottom nosing. Here's the point for this. Again, this is simply a vertical line, so we use the framing square. Oh, okay. Now, let's go ahead and draw in all these steps. Okay. Now we need the framing square that we developed this angle for the riser. This is the aluminum one. Correct.
Now the lines that you're transferring, that's for the finished concrete.
Right, right. We have to go down our 2 inches yet. Now, you really don't need to show that finished concrete when you're laying out the stair because you're not pouring it, you're not setting the pans in it.
Right.
You can simply, after you've developed this point, lay out this step, come down your 2 inches, come back your 1 inch, find out where this point is, draw a new line across your stringer, right across this point, and that 1 9/16 or whatever it was is exactly the same here as it will be right there to right there.
So as opposed to this 2-inch line,
Mm-hmm.
you'd be working off a line.
Whatever this dimension happens to be from your layout.
Okay.
And that'll change whatever the slope of the stair is. But I wanted people to be able to see the relationship of everything. So again, we draw on our 2 inches for our concrete. Okay, now that we've got the transfer, we can go ahead and trim this piece of channel. Okay, and here's a little better view of what the thing looks like. Now that we put our layout lines on it, prepare it for cutting and trimming. Okay, I've added a stray edge, clamped it to my work surface to ensure that I get a much straighter line rather than just going freehand. Okay, now we will lay out the cut for the mating piece to this, and as you can see, it's the reverse angle of what this one is. Like I say, if we needed this for the other stringer, we would hold onto it and cut another piece, but that other stringer is not going to have a tail on it. So just transfer our line once again and get the torch back out. Okay. Now that we've made our cut with the torch, we have to clean it up, and we are going to actually bevel this edge, both pieces. Because when we put this together, we need a full penetration weld for structural stability. Now that we've got it cut and ground smooth, ready for welding together, we've had to use a few little pieces of shim stock to ensure that we are flush across here. We don't want the two stringers to be canted with one another. We then take our framing square. Again, here's our level line. We'll use the straight edge to ensure that this level line is parallel with the bottom of the channel. We're ready to weld the two pieces together. I will tack in a couple spots and then start my weld. Okay, we've got the two pieces tacked together to hold their direction this way. The first two welds you have to accomplish are the verticals on the sides, along here and along the back side. Once that is accomplished, you roll the entire piece over and fully weld the inside of the channel first. Also, you want to probably have a 1/4 inch spacer near this joint so that in about 3 feet we have a little bit of a taper down. By the time you finish welding this piece, the two ends will pull back in alignment with one another, so we're in a flat plane. You don't want the tail going off at a cockeyed angle. Okay, we've welded that vertical, now we come over and weld this side. Our next step now will be to trim off the bottom of the stringer, cut at the vertical line and across the floor line. Okay, we have now cut and dressed this end of the stringer. I've cut a piece of 1/4 by 1.5 bar stock to create a closure plate for the end of the stringer. I've got it clamped in place with a clip angle. I will next tack it, remove my clamps out of the way, and then finish weld it. This is not a structural piece, it's just for decorative purposes only, to close the end of the stringer so you don't see a hollow spot. Okay, we have finished the lower end, made our miter joint. Now we have to trim off this end. We'll continue our layout, which I have done already. At 38 inches, working off the nosing, the top nosing is our working point. 38 inches back is the length of that stringer. We've got a line marked here at 38 for the cut. 34 inches back from the nosing is where the face of this clip goes. This will bolt into a header channel. We've marked where the center of the hole should be. This line represents the face of the angle. This line crossing it is the center of the hole. We have the center of the hole marked on the clip. And we just make sure those are in alignment because there is a mating hole in the channel that it attaches to. Here we have a carrier angle for the landing. That goes right up to the concrete line, the bottom of the concrete line. This end we have another header channel going across to carry the inside stringer. 2 holes in that. They're marked here, and on here we line those up. And then our clip to bolt the thing to the floor. Again, we have a specific dimension to work from off this nosing. Generally, this clip can go pretty much anywhere in this area. You only have to worry if there's might possibly be something in the way, and you have to be out of the way of your riser plate. So that clip will be right here. The carrier bars, you can see that we have 3 treads on this stair, and we have 3 different carrier bars. These 2 lengths is for the riser, and this one. That's because the one happens to be the top riser. It's got a short leg before it comes back. The bottom one is a shorter step because there's no concrete fill below it that we have to worry about. That will line up right at this position. And our normal carrier will fit right in this. Now if this were like a 12 riser stair, the top and bottom would be different once again, but the middle 10 would all be exactly the same. So our next step is to weld all this stuff on. cut off the end, finish the other stringer, and then go ahead. We'll do a small assembly here on the other end of the shop. We've brought the opposite side stringer in alongside this one so you can see at the bottom they are identical but opposite hand. The same as carriers. This one, we were given a 3-inch dimension from the nosing to the face of this channel, the same 3-inch dimension we have on this one. This one, instead of having a tail on it, has been cut off at a vertical line. That's so that this surface will go up against the side of this header channel. Again, a small erection clip to aid in the installation process. All right, we've brought the completed stringers over to this little platform area so we can do a simulated assembly. First of all, this is the wall stringer. The end of it has been cut so we can create a smaller pocket to extend it into a masonry wall. So this tail here would be into the masonry wall. This surface here would be the face of the back wall of the stairway. This clip will accept this back channel. Since it's going up against the wall, there's a nut welded on the back side already because you can't get your hand behind there. We'll bolt that in place, support it at this end with a piece of pipe for now. This would normally either go all the way across the stair opening and bolt into another stringer or pocket into the block wall as the end of this one does. This is the header channel. It will bolt into this clip. Would normally go across again to the far stringer, or itself would also pocket into the side wall. We will hold it up temporarily with this pipe, and this is the header that will carry the inside stringer of the stairway. At this point, I'd like Lloyd to join me, give me a hand installing these two channels. Again, this is the back wall channel, the 3/4 inch structural bolt connection to the sidewall stringer. You'll see that this is the same size channel as the wall stringer, so we can maintain this 4-inch curb above the concrete line around the landing. It's also just a junior channel. All we need to do is carry half the load of the platform. We're not carrying any of the load of the actual stairway. That will be carried by the header channel in front of us. Again, we'll just set this in here temporarily. Hopefully it doesn't fall over. Now we get to the header channel, which is an 8 at 11.5 pound structural channel. Again, as I said, that will be carrying the weight of the stairway as well. And there's a 2-bolt connection on this one.
The staircase we looked at this morning to measure, how long would you anticipate the installation would take on a project like that?
Probably about 2.5 days for the stringers.
And that would be pans in place?
Right. Again, as I said, the ends of these channels would either bolt up to the far wall stringer or pocket into the wall. But for our purposes, we just have a pipe underneath them to hold them temporarily. Okay, we've set the back wall channel. We've set the header. In a typical installation, this wall stringer, back wall, and the next wall stringer up to the next floor, those will all be installed first. Your header channel put in place, and then it's time for the center stringer. Lloyd, if you'd bring me a pan, we'll help locate this center stringer properly. Again. Again, the little clip angle we welded on the back of this channel makes this nice and easy. Set it right on there, clamp it in place. We don't have to worry about it falling over. At this point, we'll need 2 pipe clamps. one for underneath the stringers. They'll clamp the bottom flange, and one for the top to pull the thing square to the pan. Let me go ahead and slide that one in there too at the same time. This is always a good sign when two pans go in. Let me slide that underneath to you. Need more?
A little more. I'm fine.
Okay. Just snug it a little bit. Having the clamp above and below the pans ensures that the stringers are completely square against the pans. And that's why it's critically important when you have your pans made, whether you do it yourself or have it done out, that whoever's doing it forms them in a very, very square shape. Next step would be to go ahead and weld the pans. We'd put 2 good welds along the side, and then we would weld this surface against the back side of this surface here on the inside with about 4 or 5 1-inch welds across the back side. That makes a very rigid stair, very unmovable. The last thing you do is put the starter pan, which is that, I don't know if you remember back when we were on the sheet of paper, I showed you all the different styles of pan. That one's just a vertical riser. Here's that other special pan I talked about. The vertical lip that you saw in the normal pan in just a little short distance. This closes the space behind this top riser and covers the distance to this back channel. Now, as I mentioned, we normally assemble the stairs from the bottom up. I should mention that we always leave this bottom pan out, start with the second one, work our way up. Then we can, when everything we're sure is fit, we go ahead and bolt the thing down in place, put in that last pan and the riser. Again, I said some guys do start from the top, have to work off ladders to begin with, work their way down, and basically end up doing the same thing. The last pan to go in is that bottom one so they can bolt it down. This is the corrugated galvanized decking material which creates the form for the concrete on the upper landing. It would simply lay in place. There will be some notching required by the installer for it to lay nice and flat. In this area right in here, it has to be notched around this stringer. You could try and do it in the shop. You might be off a little bit. It's just as easy for him to do just a little bit of work in the field. The thing will lay nice and flat on top of all the support channels that we talked about earlier. We're going to do a brief recap of the things we've discussed throughout the video. Some of the important elements. Obviously one of the most important things is getting those field dimensions correctly, getting them back to your detailer so he can correct the drawings and get the proper documents out to the shop to fab from to begin with. One of the most important elements on the stair, again, the relationship of this tread length to the riser height. That creates the angle, and also what this miter point is. If you don't get that correct, the entire stair will have to be redone. You can make this a little bit too long. It's easy to cut off. Make it a little bit too short, weld the piece on. A simple fix. Another thing we want to caution you about is this is simply an erection clip just to hold this stringer up temporarily. You have to go back afterwards and fully weld this connection to make it a structural connection. These clips on this particular stair are structurally sound. No further welding is required. Sometimes these are just, again, temporary erection devices, in which case this has to be fully welded. Be aware of the fact that this concrete at a landing will probably be thicker than the concrete on the tread. This top riser here will lay out slightly different than the bottom. All the ones in between, whether it's just one or whether there's 12, will pretty much all be exactly the same. One other thing I want to caution about, as you saw, we use the pipe clamp to pull these two stringers together. If this is up against the wall, you can't use a normal pipe clamp. We've got several where we've welded some thin plates that will slide in between the wall and the stringer, And when that can't be used, we will take a 4x4, cut it about 4 or 5 inches shorter than the distance from the face of this web over to the far wall. Use another piece of 4x4 to just wedge that and push this stringer against the pan, against this one, against the wall to get a nice tight connection. There are other ways we can enhance a stairway such as this. This is pretty plain, if you will. There are moldings available that you can dress up a stair. Here's one of them. Has a nice shape to it. You can put one here at the top and one at the bottom. Create some nice detail to the stringer. Here's an end view of it showing its shape. Pretty ornate. Now if you've got any other questions that I think we might, most of this information from today is available in this little booklet is available from the foundation. It talks about many of the same things we did. It even shows you how you can create one of these framing squares with a guide bar to lay out the slope on your stair.
Well, Chris, today you have field measured, you have created your shop drawings, you've done your fabrication, and part of your installation. What else is there left for you to do on this job?
Most important thing, send a bill.
There you go. This concludes our demonstration on steel stair fabrication. I want to thank Chris Meitner of Christopher Metal Fabricating and hope that you found this beneficial. On behalf of the NOMMA Education Foundation, thank you.